This is Chapter 7, Lewis Structures, Homework number 4. What is the Lewis structure of the polyatomic anion? This polyatomic anion is formed from bromine and fluorine, but it carries a -1 charge. So first we need to identify the total number of valence electrons. So in this polyatomic ion, in order to do so, let's find out the valence electrons for both bromine and fluorine. Since both are in the 7A group, so each should have 7 valence electrons. So the total number of valence electrons can be calculated, of course, using 7, that's for 1 bromine, and then 2 plus also 7, that's for the 2 of fluorine, and that should give us, so that will give us 21, all right, but don't forget this is a polyatomic ion. An ion, so it carries a -1 charge. What does it mean? It simply means it has 1 more electron there. You have to add that one. Okay, so therefore that's total of 22 valence electrons. Now let's take a look at the electron negativity of bromine and fluorine. Okay, so since the electron negativity increases from bottom to top, so which means fluorine is more electronegative, bromine is less electronegative. Therefore, bromine should be the central atom. Now we can write the skeleton structure like this. Bromine is the central atom. Okay, now we need to assign the valence electrons to the peripheral atoms first and make sure they satisfy the octet rule. All right. Okay, now you can see the fluorines, they have a total of 8 electrons. Remember the single bond that count as 2 electrons. So that's total of 8 for this fluorine, also total of 8 for the other. So for bromine right now, it has 2 plus 2, that's 4 bonding electrons. Would need 4 additional electrons to meet the octet rule. Okay, so now assign 2 lone pairs, each 2 electrons. So that's 4 lone non-bonding electrons plus the 4 bonding, that's a total of 8, all right? That's 2 plus 2, 4 plus 2, 6 plus this 2, that's 8. So that meets the octet rule. But please note, if we already count those bonding electrons for the fluorines, so therefore when we count the number of electrons, the non-bonding electrons. So for bromine, actually there are only 1, 2, 3, 4, only 4 electrons. Even though it does have 8 electrons surrounding it, it meets the octet rule. But the actual number of electrons we assigned after the bonding electrons for bromine is only 4. So therefore, that's 8 plus 4, 12 plus 8. It's only 20 electrons, all right? But there are 22 valence electrons. What do we do now? We assign the remaining 2, the last 2 electrons, to the central atom. So in this case, bromine. Of course, this does not meet the octet rule, but that's the way you do it. You don't assign the additional ones to the surrounding atoms. Okay, what do we do with the minus sign right there? Because it's an ion, we have to specify that. So this is not a molecule, it's an ion, okay? So now let's take a look. You see, bromine has a total of actually 10 electrons surrounding it, while fluorine, each fluorine only has 8. So obviously, there's greater electron density around bromine. That's why actually that negative charge is contributed more by bromine than fluorine, even though fluorine is more electronegative. So therefore, this should be the correct Lewis structure for this polyatomic anion.